From concept cars to consumer vehicles and new forms of mobility, today's technology is focused on sustainability more than ever. As manufacturers hope to realize their latest innovations, the modern smart city is evolving to match their vision. Welcome to City Digital, presented by DigiKey, powered by analog devices and SupplyFrame. In this episode, we discover how cutting-edge technology surrounding energy management, artificial intelligence, and advanced simulations are reshaping the manufacturing landscape. David Lath, staff engineer at the Analog Devices Sustainable Energy Business Unit, shares how energy management plays a role in bringing to life the sustainable support needed to power autonomous transportation in today's smart cities.
Some of the difficulties in the energy sector right now is decentralization. Previously, there was a power plant and then the transmission and distribution system, and then it went to your home. Now the homes are becoming kind of independent energy sources, and you hear about microgrids and everyone has solar on their home. People have EVs. It's becoming a more distributed and complicated system. And then the other piece, in order to manage all that, just the digitization of the grid. Being able to have information of what's happening at these, we can call them edge nodes, at the home, at the factories, in the industrial locations, what's going on, what the power looks like. There's gonna have to be a lot of technology that goes into it in order to get the insights necessary to manage the grid. Everyone knows ADI for their hardware or for their ICs. But on top of that, we're adding in software, we're adding insights and more technologies in order to improve the efficiency of the grid. Making our technology more compact so that it can go into more areas. Now you can have insights into parts of the grid that you wouldn't have had before. By having this information, utilities and grid operators are able to better manage the grid, make sure that there's less brownouts, less blackouts, less energy loss, making sure that they're running as efficiently as possible.
Warren Honor, an innovator in the autonomous driving space, describes how digital simulations can streamline and optimize the manufacturing process to avoid delays or unseen issues before they emerge.
The majority of design is done exclusively in simulation for testing. We've seen it as a precedent in aerospace. Every airliner you've ever flown in has been heavily tested in simulation. That's the direction we're going to see now, especially as cars get more and more complicated with software as the focus. It's simulating the body control systems, the rigidness of the chassis, the noise, vibration, harshness of the ride quality. When you go down the road and you experience that feedback in the steering wheel or that bump in the seat, that was put there by design from the OEM. But we also do hardware in the loop testing. So a company can bring their forward collision radar and put that in the loop with the software. So they can send signals to that hardware unit and actually receive feedback from the hardware system into the power control module to actually see what the native CAN messages are, what the response rates are. There are tier 1 suppliers that are working with us to develop the ultimate package that they're selling off to OEMs. And then there's some of these smaller companies that are designing next generation sensors. I know I have a lot more confidence as a road user. I ride a motorcycle a lot. So when I'm splitting lanes or going through traffic, I get a lot of comfort when I see a little orange light pop up in someone's car mirror, because I say, hey, even if they don't see me as I'm approaching to pass them, their car sees me. Along the way, all of us benefit by having the safety systems active around us.
Matt Melke, an applications engineer at DigiKey, provides additional insight into how artificial intelligence and machine learning will play a growing role in the future of sustainable mobility.
I mean, AI is all over autonomous vehicles. For real-time applications, the hardware needs to be powerful enough to process the data and provide a rapid response, right? And if you've got a deep neural network that has to go through all these parallel operations to go from one end of the network to the other, then the hardware needs to be able to keep pace. A lot of our vendors are providing tools and libraries that allow you to implement a neural network or an artificial intelligence algorithm and then scale it down to the level where it can run on this lower level hardware. Customers will come to us all the time looking for a functionally equivalent part that they could use, and sometimes then they'll need help transitioning to that part. If I see a new product that just came out and it looks interesting to me, I want to play with it. And I'll come across lots of issues in doing that, so then of course other people are going to have those same issues, and that's where I get my ideas for the application and documentation.
The evolution of technology is driven by the vision of its creators.
The grid itself is this enormous system that is going through a revolution, not just evolution.
There's such a wide variety of products that are needed for any industry nowadays. So it's not just sourcing them, but also getting them to work together and to do it quickly.
It's not just about saving yourself and protecting your car, it's about protecting everyone on the road.
I think there's a lot of creative ways of thinking, what does transportation mean to us? How does transportation fit into the future city?
And with each passing design, we move one step closer to realizing the future of city digital.